Welcome back. In this Snowflake certification series, today we are going to discuss on the domain 3, the performance concept in the Snowflake. So this is the weightage of the third performance concept. It is 10 to 15%. You can expect the question in your certification. So it will be approx 7 to 8 questions you can see in the certification. So these are the objectives of today's session. So today we are going to see what is the query profile or the explain plan. Then we are going to see the virtual warehouse and its configuration. Then how we can tune the configurations to improve the performance of the warehouse. And then we can see the last part, the query performance and how we can optimize it. So as a part of this 3.1, explain the use of the query profile. So what is the query profile? We need to understand it and we need to discuss these points: explain plan, data spilling, use of the data cache, micro-partitioning, pruning, and query history as a part of the query profiling. Okay, so the explain plan or the query profile in Snowflake is a tool to analyze performance of a query and optimize the system by identifying inefficiencies. So basically the explain plan is provide the snapshot of a query, how it is going to be executed, where are the bottlenecks, and we can use this knowledge to optimize our query. We can optimize the query. So the next point is the data spilling. So what is data spilling? When the warehouse is unable to store the data which is written by the query in its RAM memory, the data is going to be stored on the disk. Okay, so this is called the data spilling. Use of the data cache. Okay, use of the data cache in Snowflake improves performance by reducing the need to read the data from disk. Okay, so data cache means it stores the data into the RAM and it's avoid the reading the data again and again from the disk. Disk in the sense the warehouse or the actual storage from where the data is residing. Micro-partition pruning means, as we know in Snowflake, data is stored in a micro-partitions. So with this help of pruning technique, Snowflake is tried to reduce the number of micro-partition to scan to give the output. It just try to select only those partitions where the actual data is reside. So instead of whole table scan or the whole micro-partitions scanning, it just try to scan the particular micro-partitions. Query history. So query history in Snowflake is a feature that allows users to track and analyze past query performance. Okay, so the query history, we need to remember one point, like for how many days Snowflake keep the query history. So by default it is 14 days it keeps the history of your query. Okay, and you can just see the output of the queries which your user has executed. You cannot see anyone else data. Anyone else means if the query is run by any other user, you can just see the details of it when it is executed, when it is completed, but you will not be able to see the data for that query. Okay, so let's see this thing on Snowflake query, how we can get the information from the explain plan. Let's move to the Snowflake screen. So this is the sample query I have taken to explain the explain plan and the query profiling. So let me execute this query and see how we will get the query profiling. So when we execute the query, if you want to know how to get the query profiling, there is two options. One is go to the history, refresh this and click on the query executed the last and click here. In the go to the profile section and there you will see the explain plan. The second option is from this tab you can directly go to the query ID, the latest one, and then you can come up here in the history, in the details, then you can click on the profile and you will see the profiling of that. Okay, so let's go in the detail of this. So what all things are available in the profile? So you can see there is total 4 parts. One, here you can see how many steps are involved to execute this complete query. Second, the middle part, this is the tree node where you can see how the query is running and how is the data flow. So you can see from table scan it returned 5 rows, and then aggregate. After aggregate it returns 1 row and it is showing the result. This is the third part where you can see the most expensive node. So it will list down any expensive node in the query in a manner like first is the most expensive, then second, then third, in that way. The fourth way is the profile overview. So here we can see the overall total execution time, total statics also we can see, where the total byte scanned, percentage scanned from cache, and the pruning related information. Here we can see the partition scanned is 1 and partition total is 1. That means it is not done the pruning part. Okay, so the data is stored in only one partition, so it is not make any meaning in this. But if you see here, suppose partition total is like 8,000 and partition scanned is 20 only. Okay, so that way, that is the best part where the query use the pruning of micro-partition, and out of 4,000 it is just reading the 4 micro-partition. And we know what is the micro-partition. Micro-partition is the smallest units in the Snowflake where the data is stored. So let's see this part. So as I explained, the first part is the query. It is doing the table scan. This is the basically subquery. Okay, if we click on the second tab, second step, let's just zoom out this little bit and make it here. Yeah, so you can see the total execution. So you can see the arrow direction also, right? So this is how the result is showing in the last. So it involves the table scan of the X table, Y table, and from the Y table it is filtering the data based on the condition, and from the X table it is joining the data, filtering it, and then again applying the filter, and then these two tables are joining, then aggregating, and then the result. So this is how you can see how our query will be executing in a steps manner. Okay, so there are okay, let me go to again here. So there is one more thing. If I execute this query again, let me run it. Okay, and this is the last one. Let me run. Oh wait, sorry, I did this alter session set used cache result as a false. Okay, so if I execute this one and let me run this one, so by default this properties is set it true. That means Snowflake is intelligent, it will going to use the result cache. Okay, so this time I have executed it, and let me show the profile. So you can see query result reuse. That means we have executed the same query before and the data is already in the cache for this output, and if we are executing it again, then it is picking the data from the cache only. Okay, so that is the one of the feature in the performance. If we are not changing anything in the query and there is no change in the underlying data set, the Snowflake will return the data from the cache only. Okay, let me take you to the documentation. There I will explain some more part of this profiling. Okay, so we are now in the documentation part, and you can see I'm using the similar kind of query here to explain the same result. Okay, so you can see it is executing the 2 steps, and then we have this node, then we have this node by execution time, and this is the overall profiling. Okay, profile overview. So if you see here, when I click on the join, right, you can see all the the execution of it, processing, how much percentage time it took, remote disk IO, initialization, in the scan also how many byte is scanned and how many bytes are returned from the cache. Hmm. And here nodes by execution time, you can see join, aggregate and table scan. So how much time it took? So join is the costliest in this case. It is taking around 50% of the time. Okay. Now if you click on anywhere, you will see the data related to that only in the overview. Yes, so you can see this. One thing I want to explore, means I want to let you know one thing, how you can get the meaningful result of it. So for suppose this is the example when you are checking any query, and if you see in this table scan, it is returning 772 records, and from this table or after joining, it is returning 816 records, but after this joining you can see 235k. Okay, so you can see two tables are having only around hundreds of records, whereas the joining is giving us the record in the thousands, right? 235,000. Okay, that means the joining condition is not proper and we are kind of doing the cross joining or something. So this is a example of join exploding. Okay, second thing, union without all. So you already know, right? Like when we, what is the difference between union and union all? In union all, it is not doing the aggregation, and union is like it is performing two operations, union all and the aggregation. So we should use, whenever we know like the data is not duplicate, always use the union all instead of union, because union is having two operations underneath. Okay, and also the pruning is we can get the information. So out of how many micro partitions, we are scanning it. So if it is like always the table is storing in 1000 micro partitions and our query is not having any where clause, then obviously it will be read from the all the micro partition. But if it is having the where clause and we are getting the data of from the all the micro partitions, that means it is not doing the proper pruning and our data is scattered in all the micro partitions. Okay, so this is how you will get the knowledge from the profiling. Okay, let's move to the next point. So we have seen all these points in the query profile. So what is explain plan, the data spilling, use of the data cache. So whenever a query is returning, means if we are executing same kind of query, we are getting the data from the data cache. Micro partition pruning we have also seen, and query history. So you can go to the query history tab and there you can see the previously executed queries. So now let's move to the second point. So the second point is asking about the virtual warehouse configurations. Okay, so what all the configurations? Multi-clustering, warehouse sizing, and warehouse settings and access. So what is multi-clustering? So multi-clustering in Snowflake is a feature that allows for the creation of multiple clusters within a single virtual warehouse to improve performance and manage resources. Okay, so this multi-clustering is a cloud feature where we can add multiple nodes of a similar configuration to enhance the performance of the task, right? So in the Snowflake also in the similar way, in Snowflake we can configure it to use the multi-clustering and we can add the similar types of node in that and enhance the performance of it. Okay, so in this multi-clustering there is two concept. One is scale up and one is scale out. Okay, basically scale out is the part of the multi-clustering. Scale out means, suppose in a warehouse we have only one cluster. Scale out means we can increase the number of warehouse in it. Okay, that means if we have the small size of one warehouse, we can, or one cluster, we can increase the number of clusters and make it as 2 5 3 something like that. Okay, in which case we should go for the scale out when the number of users are more. Okay, or the requests are more. In the multi-clustering or the auto scaling feature of the Snowflake, how it will work? Suppose there is a limit of the queries which can run on a single warehouse. If the queries are number of more than the set limit, it is going to be spin up a new same kind of cluster in it. Okay, we are going to see that in a soon in a Snowflake screen, what all the settings we need to change in it. Okay, warehouse sizing is also a very important parameter in the performance side. Okay, so warehouse size means, as we know, Snowflake warehouse comes in different sizes: extra small, small, medium, large, extra large, right? So it depends on the configuration, the memory, the local memory, and the processing power of that node. If you are going with the larger size, the memory and the execution power is more in that warehouse. So we need to choose a specific size for our query and or our jobs. So we can discuss that in later, how we can choose that part. Then there are certain settings we can do where we can optimize our warehouse, we can monitor our warehouse how it is working. So there are the management and control of user access and configuration option for a specific warehouse. So we are going to see those in a on the Snowflake screen. Let's move to the Snowflake screen. Okay, so we are now in the Snowflake screen, and you can see on the top we have the warehouses. In warehouses, you can create any warehouse, you can configure the existing warehouse. Suppose I'm selecting this, and we can configure it. Okay, so what all the options you will get in the configuration of it? Okay, so first is the size. We can decide the size of the warehouse, and you can see the computation or the charges for that warehouse is varying as per the size of the warehouse. Okay, so you should just remember this credits also. You may get some questions on the credits. So for large, how many credits per hour will be charged? Next is the maximum cluster. Okay, so the maximum cluster is the maximum number of cluster can be scale up as a part of this extra large size. Okay, if you select only one, that time you can see there is one option was not available. Okay, this is the feature of the multi-clustering warehouse. Okay, let me give it as 5. Okay, now it is asking what is the minimum cluster. So what do you want to keep as minimum? So suppose I want to keep 1, or for example I can take 3. Okay, let me take as 3. Okay, what it mean? So in this multi-clustering, minimum cluster is 3, maximum cluster is 5. So whenever this warehouse will start, it will start with the 3 cluster and it can go up to the 5 cluster. Okay, so you will also see some questions related to this multi-clustering. The next point is the scaling policy. So there is two types of scaling policy. One is standard and one is economy. In economy, Snowflake is try to wait to execute the query for a particular time. If that query is not completing within that time and there are more queries in the queue, then it will start it. Okay, so it tries to save the credits of Snowflake. But in the standard option of the scaling policy, as soon as there is new query is coming and there is no space on the current warehouse, it will start another cluster of it. Okay, auto suspend. So this feature is like when your warehouse is not in running condition, it will go into auto suspend in 10 minutes. So ideally for this, in your project or anywhere, you should set it to 60 seconds only. Okay, you can see it is not available here, but if you click on show SQL, you can see the auto suspend time here. So auto suspend time you can set it as 60, and means copy this SQL, and whenever you are executing you can make the change. Okay, auto resume means whenever this warehouse is idle and you are executing the query, it will be auto resume. Okay, it is not like if you do not do this auto resume, then you have to manually start that warehouse and then only your query will be getting executed. Okay, so let's create this warehouse and I'll show you this auto suspend time, how you can change it. Okay, so I'm not executing from here, I'm going to the worksheets and I am running this statement. Okay, before this I can make the change here and make it as 60. Okay, so I am executing this. Now we can go and check the warehouse. Okay, so let me open. So you can see the minimum and maximum cluster we can see here, and the auto suspend time is 1 minute, and this is the custom one. Okay, so ideally, if in this case your warehouse is running for 1 hour and it is ideal, it will be going to turn off. Okay, now the other points are how you can increase the number of these clusters, right? Or how this scaling policy work. So if I start this warehouse, right? So let me resume it. I'm executing it, and you can see it is showing as 3 as active, right? Why? Because we have set the minimum as a 3. So it will be charging me $3, 3 credits per hour. Why? Because for one cluster it is 1 credit. For 3 cluster it will be charged as 3 credits. So I'm going to suspend it, but I suspended before 60 seconds. But if you remember, the Snowflake will charge minimum for the 60 seconds, and that is also the cloud policy. So most of the cases, in whenever you are starting any EC2 machine or anything, it is first time you will be charged for the minimum 60 seconds. Okay, there are other features. If you click on this warehouse, you can see warehouse load over time. Okay, this will show you the aspect of the query execution, how it is running, at what time your warehouse is mostly occupied. Okay, so you can see at this time I executed query, here I executed query. So in your production environment you can see some pattern in this. Okay, suppose if you have your workforce in one geographical location and your jobs are running, or your team is working from 8 to 5, then you will see most of the usage from morning 8 to 5 p.m. Okay, and that is how you can check the behavior of the warehouse, right? The other thing in the warehouse, what you can do, the resource monitoring. Okay, so to set the resource monitoring, you need to go to the accounts tab and you can see the resource monitor. Okay, so click on the resource monitor. This resource monitor, suppose first monitor. Okay, it is asking how many credits quota. Okay, so suppose I am giving 60 credits quota, so that means in a one cycle, in a 1 month, I can only consume the 60 credits. Okay, monitoring level, at what level I need to check it, whether it is at warehouse level or the account level. Warehouse level means it will be just checking for the particular warehouse, and account level, inside the account there can be multiple warehouse, and it will be checking or setting the limit for the entire account, but I'm going for the warehouse only. Okay, so which warehouse we want to monitor? Compute warehouse. Scheduling also we can implement from right now or the beginning of the month. That is all we can set. So what actions we need to take it if this credit is used more than this credit quota. Okay, suspend and notify when 80% of credit use. For example, suspend immediately and notify me when 95% of credit use, and notify when 50% use. So this is some kind of settings we can do, and we can add other notification threshold as well here. Okay, we can create it. So you can see our this warehouse resource monitor is created. This is how we can uh, optimize our credits use, right? So this way you are not going to go beyond this 60 credits, because we have already set up the limit of 95%, and when it is reaching the 95%, and it is going to be suspended, and no one can, without having the account admin access, they will not going to resume it again. Okay, so this is the use of the resource monitor. So let's go back to the PPT what we have. So we discussed about the multi-clustering, the warehouse sizing, and the warehouse setting and access. Okay, now let's move to the various performance tool. So monitoring warehouse load, query performance, scaling up compared to scaling out, and resource monitor. So we already discussed this resource monitor. We will go on in deep in the scaling up and compared to scaling out. Okay, what is the scaling up? Let me go here in the warehouse and just configure it. Okay, scaling up means you are increasing the size. Okay, currently I have extra small and I am going to the extra large. Okay, so this is the scaling up I am doing. Okay, the second one is when my maximum cluster is 1, that means I can have only one. Okay, I can increase for 10 for example. This is what I am doing, scaling out. Okay, so scaling out is automatic feature where if your warehouse is having more load, it will automatically, based on the scaling policy, it will increase the number of clusters. Okay, so this part is automated, but when you want to increase the size or scale up the warehouse, you need to do it manually. Okay, so there is two difference. The main difference is the scale out is automatic and scale up is manually you need to do. And if your query is already executing in extra small example, and if while running the query, if you change it to extra large, your current query will not be moving forward to the extra large. You need to kill that query and you need to re-execute it if you want to change the warehouse of it. But any new query, and you just change this warehouse size, right? Any new query will be going to the extra large warehouse only. Okay, and in which case this including of cluster will work whenever you are having many number of users. Okay, they are trying to hit it. In that case, we should go for the scaling out as compared to scaling up. Scaling up, we mainly go when we need more compute resource and more memory, and cluster we go when we want to achieve the concurrency. That means number of users, they are executing multiple queries simultaneously. Okay, so this is the basic difference between the scaling up and the scaling out, and you will see 2-3 questions based on this. Query performance and monitoring warehouse loads, we have already seen this warehouse. If you click on this, you can see it here, how this warehouse load over time. And query performance is like you need to play with the warehouse sizing. Suppose you have very complex query, the best approach is, as the Snowflake is also mentioned, start with the lower one. Okay, if it is not giving you the expected output in the time, just try to increase the size of it. Okay, there is no hard and fast rule for this type of query you should go with this size of warehouse. It is, you need to play it with the sizes of the warehouse, then only we will get to know which is the best warehouse we can use it. And most of the cases, I'm not asking about the production loads, but in the dev day-to-day work, if anyone is working and the query is not that complex, always use the extra small warehouse. Okay, this will lower down your credits. Now we can move to the next point, that is optimizing query performance. Okay, how we can improve the performance of a query. So for that we can do two things. One is the materialized view and use of the select warehouse command, select command. So what is warehouse materialized view? We know it, right? If I ask you what is the difference between view and materialized view, okay, so view is, it is just a skeleton, and whenever you are hitting the view, it is executing the underlying query multiple times. Whenever you are hitting it to the it is going to the actual table, and it is always using the compute credits and other. Okay, whereas materialized view is like, once you can execute the materialized view refresh, that time the materialized view will be refreshed from the underlying tables data, and it is a physical store, right? So whenever you are hitting the materialized view, it is giving you the data, and it will be refreshed once, and you will always get the latest data out of it. Okay, and as you are just going to fetch the data from the materialized view, and it is not going to hit again the query, the underlying query, that means you can save the your compute credits. So materialized view is preferred over to the views when your data change is minimal. So the frequency, suppose it is 1 day of the underlying tables, so in that case we can go to the materialized view. Okay, the next part is the specific command, how we can use it. Okay, so to improve your query, you can use the select distinct and limit and where clause. If you are using these all conditions in your query, it will be giving you the less subset of the data. Okay, so in where clause, the query pruning will be work and your query execution will be faster as compared to the normal and without where clause. Limit is also one of the option where you will see the limited data out of it. Okay, so this is all about our this query performance tab. Let me know in the comments if you have any question, and thank you for today.